bone cells broadcast inflammation signals directly into your nervous system. We often treat skeletal issues as just localized aches or fractures, thinking the bone lives only there. But this ignores how complex and regulatory your skeleton truly is. Deep within the matrix of hard tissue, specialized osteocytes are generating signaling molecules that reach far beyond local repair sites. This whole chain reaction we call cytokine signaling effectively allows the health of your mineral structure to modulate systemic inflammation levels and even influence regional brain function, acting like a silent internal endocrine regulator controlling mood stability over time. Strain placed on bone tissue does not just signal damage to local repair teams. Specialized cells within that matrix, called osteocytes, are incredibly sensitive transducers of mechanical stress. This process of mechanotransduction acts as a biochemical broadcast tower. When load changes, these lacunar cells release specific inflammatory cytokines like IL-6 or TNF-alpha into the surrounding microenvironment. Crucially, this signaling cascade does not just stay local to bone remodeling cycles. It directly interacts with peripheral nerves and influences the resident microglia in nearby neurovascular units. This establishes a direct feedback loop where skeletal homeostasis actively participates in regional neurological tone and autonomic system stability. Inflammation signals moving through this osteoneuroconduit do not just affect local brain activity. They propagate far beyond specific nerve endings and influence systemic metabolic rhythms too. Think about how persistent low-level inflammation can disrupt sleep architecture or destabilize glucose regulation in ways we never connected to calcium turnover before. This constant background noise, generated by the subtle shifts in mineral homeostasis deep within your skeleton, drives a state of generalized physiological drift. It contributes to that quiet exhaustion you feel even after getting enough rest, and it subtly affects how effectively your body manages stress hormones day over day. How does the physical integrity of bone tissue become this unseen engine driving metabolic burnout? These subtle chemical messengers do more than influence sleep rhythms or hormone levels. They initiate a highly targeted biological conversation directly within your central nervous system. The chronic background noise originating from skeletal stress does not just cause systemic drift. It primes regional immune defense lines for heightened reactivity, particularly at the blood-brain barrier interface. This mechanism allows circulating signaling molecules to subtly destabilize microglial populations in critical neural zones. These local resident cells become altered by bone signals and begin responding with an inflammatory bias long before any obvious neurological symptoms appear. How does this low level of systemic priming eventually lead to functional decline in memory or cognition? This sustained inflammatory state does not just cause a temporary spike in reactivity. It fundamentally rewires how neurons maintain their internal power grid. The altered local immune environment begins to starve adjacent cells of mitochondrial efficiency, leading to chronic energetic deficits within the regional neural networks. When mitochondria fail to operate optimally inside these brain support structures, function declines not through damage, but through sustained energy depletion. The slow systemic drain means months pass without noticeable decline until those subtle failures in cellular maintenance translate into measurable memory issues or processing slowness. How does a mineral imbalance deep in your skeleton begin dictating the quality of every single electrical impulse across your entire brain? How does that internal conversation ultimately determine your life trajectory? When we first mapped this osteoneuro connection, researchers held two fundamentally opposed views. One body of work viewed those persistent inflammatory signals as inevitable damage markers, a predictable cascade leading inexorably toward decline. But another, more recent set of studies shows that under certain conditions, that same cytokine activity is not just background noise. Instead, it acts like an adaptive tuning mechanism for the autonomic nervous system itself. It forces us to ask, is this bone signaling merely warning light indicating failure? Or is it a sophisticated regulatory broadcast enabling complex biological resilience? What happens when these systems reach equilibrium? What happens when that complex system reaches equilibrium? We learned this feedback loop can be adaptive, but a deeper look shows that bone tissue does not just send information. It actively filters it. Think of the osteoneuroaxis not as a simple on-off switch for inflammation, but as a highly sensitive frequency tuner. When mineral homeostasis is optimized, specific signaling molecules stop behaving like warning flares and instead begin directing microglial populations toward maintenance mode. This shifts the brain from a reactive state to one capable of sustained neuroplasticity. It means that skeletal resilience becomes an active precondition for cognitive stamina. But how exactly does that fine-tuning occur at the cellular level? When we view this osteoneuroaxis as a frequency tuner instead of a static sensor, our perspective shifts completely from decline prevention toward active optimization. The cellular fine-tuning happens when mechanical input achieves specific patterns. It is general movement, but the quality and predictability of load applied to bone. By providing structured biomechanical signals that favor anabolic over catabolic responses within osteocytes, we essentially tell the system, maintenance mode only. This targeted signaling recalibrates local cytokine release profiles, steering microglial populations away from inflammatory readiness toward genuine neuroplastic support. The single clearest mandate for maximizing this resilience is understanding how adaptive loading protocols can retune your systemic immune state through mineral homeostasis. If you want to examine the full research archive detailing these exact load requirements, visit jmthomasofficial.com now. The ultimate conclusion here is a shift from viewing the skeleton as passive support to recognizing it as an active biological regulator of your neural health. We established that optimizing bone signaling allows the microglial population to switch into maintenance mode, enabling neuroplasticity instead of sustained reactivity. This means longevity is not just about avoiding decline. It is about actively tuning this osteoneurofrequency tuner toward resilience. The single clearest step you can take now is moving past sheer volume and focusing on structured load quality that promotes anabolic responses in your bone tissue. To access the full research archive detailing how specific biomechanical patterns drive these systemic benefits, visit jmthomasofficial.com.